Earlier this year, I participated in the Black and White Game Jam, where the goal was to create a game that used only 2 colors and followed the deep as a theme. The game I came up with in the 2 weeks the jam lasted is called Elevator. In this game, you are a mine elevator operator who needs to pick up workers and drop them off at whichever floor they may require going to. If you don't pick up or drop off a worker in time, they lose their patience and you lose the game. As soon as you get a couple of workers on, the game starts getting complicated, as you'll need to make some quick choices to manage the workers' moods and be able to pick up and drop off everyone in time. I'm really happy with how the game turned out. It even placed 3rd on the rankings for the jam. Anyway, to get to the topic in this video, Elevator was built with Godot and uploaded as a web game. I wanted to challenge myself and see what it will take to port a game of this scope to the Nintendo DS. Now, of course, since the now almost 20-year-old DS isn't one of the available export targets in Godot, this meant that I will need to rewrite the whole game on top of the DS's homebrew development environment, using the devkitpro toolchains. I will have to recreate the game logic in C or C++ and use some homebrew libraries to be able to draw things on the screen, play audio, and handle the touch screen input. For these tasks, I chose to use devkitpro's libnds library, since it provides a lower-level interface into the hardware than its more modern alternatives, and I wanted to take advantage of that. I started by trying to draw some things on the screen, and right out of the gate, I realized the DS worked much differently from what I had expected. The DS contains specialized hardware to handle graphics. The constructs of sprite and background exist at the hardware level, and utilizing them is essential for getting the most out of the console's capabilities. Both sprites and backgrounds are normally rendered using tilemaps. Tilemap rendering consists in subdividing images into a set of the unique 8x8 pixel tiles that compose them, and then storing the image as a set of these unique tiles and an array of references to them that reconstructs the original image. This technique helps in maximizing the utilization of the limited video memory the console provides. I began by trying to draw the mines in the game as a background. To do this, I first had to set the DS's top screen into one of the available background modes. These modes specify the different configurations that each of the 4 background layers on the DS can take. On the layers that are labeled as text, tilemap rendering can be used, and on the ones that are labeled as extended, the more memory-demanding bitmap rendering can also be performed. I chose mode 0 since I wanted the tile-based backgrounds on all of the layers for now. The DS has got several banks of VRAM video memory, but the graphics that are to be drawn on the screen need to be allocated into. I reserved Bank A for backgrounds and copied the cave's image data into it. To test my first experiment, I compiled the game with devkitpro, copied it into my flashcard, and booted up my old DSi. I was greeted with a reminder of my sick photo editing skills from 2011. I opened the game file and saw my background in all of its glory. Okay, maybe it's not that exciting for now. Let's move on with the port. Since the process of copying the game from my computer to the flashcard every time I wanted to test something would be quite tiring, I opted to test most of my development builds with the no-cache GBA emulator. I used its debug version, which contains a lot of extra features for developing games that ended up proving to be super useful. One of these features is that I could visualize the loaded background, the tiles that compose it, and how those are arranged in VRAM while I had the game running. Moving on to the controls, I wanted to utilize the DS's touch screen for input, so I decided I would place the elevator buttons which in the original game were controlled with the keyboard, on the DS's bottom screen. The DS uses a hardware mechanism to manage sprites known as the Object Attribute Memory, or OAM for short. And here's where No-Cache GBA's debug version came in really handy, since you can see the contents of the OAM while the game is running in real time. Here we can see the sprites of the buttons that are loaded on the bottom screen. The next step was to make these buttons clickable. To do this, we simply poll the stylus position with one of libnds's functions and check if that position is within an area of the screen that we define as belonging to each button. And with that, we can turn the buttons on and off. Having the input buttons working as expected, it was time to port some of the gameplay code in so that we could actually use the buttons to move things around. I recreated the logic I had in the Godot version for going to the different floors in C and connected it with the button's states. I then ported the scrolling background, the spawning guys, and the door opening logic. As you can see, I also had all this debug text on the screen, since I still needed to add all the labels and number indicators I had in the Godot version. So I moved on to porting those next. While libnds does provide some sort of basic font rendering features, I tried simplifying my text drawing requirements by not using any font logic and taking a couple of shortcuts instead. Since most of the text in the game doesn't really change and it's fixed in position and size, I simply embedded it into the backgrounds I was already using. The numbers in the game though, like the score, level, floor, button numbers, floating numbers, and worker floor indicators are constantly changing, so I needed to create a system that could at least handle the rendering of those. What I came up with was loading a single BMP file that contains the numbers from 0 to 9 in the font I chose for the game. Then, I wrote a function to render numbers that simply takes in a list of the required sprites in memory, calculates how many of those it will need for the desired number, and then fetches the appropriate image for each slot from the font BMP and renders it. Sometimes, I would need to draw numbers with the same font but with a different color, and since I didn't want to have a separate font image for that scenario, I managed to utilize the DS's palette features to handle it. I created a palette that contained the original colors in the game, but with its black and gray entries inverted. This allowed me to change the palette for all the sprites that I wanted to invert the colors for anytime I wanted to, like when activating and deactivating the buttons. By this point, I had also ported the indicators that show up whenever a new worker spawns in one of the floors. These show their current mood and whether they want to go up or down from where they stand. One of the last things I needed to port for the game were the scene transitions. In the Godot version, there were two kinds of them: scrolling the whole screen to black and the circle focus transition that appears when a worker finishes losing his patience and makes you lose the game. For both of these, I needed to draw pixels at certain points in the screen, not tiles as I had been doing so far. Remember the background modes I mentioned earlier? Well, a couple of them, like Mode 3, allow for bitmap rendering in the layers marked as extended. So I set the screens to Mode 3 and put the third background layer on bitmap rendering mode. For the moving to black transition, I simply drew a fully black background that occupied the whole screen, placed it right below the lower limit of it, and slowly scrolled it up until the transition was completed. For the circle transition, I calculated the point at which the indication of the failure was located at. This could be the face of one of the workers in the elevator in the top screen, or the UI indicator for one of the workers on the floors in the bottom screen. Around this point, I draw a circle with a huge radius, outside of which I fill the screen with black, and reduce this radius progressively during the transition. After the transition time is up, we end up with the focus placed on the worker's face, so it's very clear which one made us lose the game. To draw this circle at any point in the transition, I started with the same logic I had used for the Godot version. For each pixel on the screen, we calculate its distance to the center of the circle, and then, if that distance is shorter than a certain radius, we set the pixel as transparent. And if it isn't, we set it as fully black instead. And when I went on to test that, yeah, it seems like the DS struggles a lot rendering the transition. With Godot, I used a shader to calculate each pixel value in parallel, but on the DS, with no way to do that, and with a fairly slow CPU, this meant I would need to perform some big optimizations to the circle rendering code. The operation that most likely was causing the big slowdown was the distance calculation. Since it involved one square root and two squaring operations, which are usually very CPU intensive, especially in older hardware. So I focused my optimizations on reducing the amount of calls to the distance function. I realized, since we know the radius of the circle, we also know that the outside of a square with side lengths equal to the diameter of the circle will be guaranteed to be outside of it. So we didn't really need to calculate distances in that area. I filled all of those parts of the screen with black. For the inside of the circle, since we are iterating through its rows from left to right, once we find the first pixel that's inside the radius for one row, we know that we can take the distance in x from that first pixel to the center of a circle, multiply it by 2, and know that all of those pixels will be inside the circle, and the rest of the pixels in the row after that will not. So we fill both of those groups with a single operation each. Combining these two optimizations made us avoid a large percentage of the total distance calculations and led to a circle transition that worked much more smoothly than before. By this point, I was almost done. I only had the audio left to work with. Included in devkitpro, there's a sound management library for the DS called maxmod. Using sound effects was extremely simple with it. I could load the same WAV files I had been using with Godot into the memory, and playing them was very straightforward. But once I tried loading the actual music for the game as a WAV file, my 40-second long background music file was larger than the entirety of the available RAM on the DS. So clearly I needed to figure out a different method of playing it. While I could have streamed the audio file instead of loading it, there's a different way in which music is usually handled on the DS, and that is using something called tracker music. Tracker music files look like spreadsheets where every row indicates which sample and note to play at a particular step of the song. This allows us to greatly reduce the size of audio files, since now all we need to store are a couple of samples and a set of instructions on which ones to play at any particular step instead of the raw audio data. Porting my background music to this format proved to be quite fun. It started out easy on the percussion side, as I was already using only one sample for the kick, snare, toms, and crash cymbals of the song. I simply exported the samples from Ableton along with MIDI tracks for them into a tracker program called OpenMPT, and with that, I had the basic percussion rolling. When it came to the guitars and bass, I first used Ableton's Audio to MIDI tool to convert the live recordings into MIDI, modified and quantized the result a bit, and exported the files to OpenMPT. Since you can pitch the samples to certain notes, I only recorded samples for 2 notes for each of the instruments. And then Set the rest of the notes to use those same samples but pitched to the appropriate frequencies. The sampled guitar and bass ended up sounding like this. They of course didn't sound as good as the live recordings I had used for the original Godot game, but at the same time, they made the music sound much more like the kind of music I associate with the DS's classic games. The music's WAV file was around 7 megabytes in size. I ended up with a tracker music file that was only 647 kilobytes, a tenth of the original one's size, which did fit in nicely with the rest of the things in memory. After mixing the sound effects and music, the port was finished. There are of course a lot of things that I had to do that I couldn't get into in the video, like how I handled memory management, background scrolling and wrapping, timers, saving and loading the score, etc. But I'll leave a link to the GitHub project in the description below in case anyone wants to take a look at the code. If you like, you can even download the ROM to play on your DS from there too. Thanks a lot to all of the people from devkitpro and the rest of the DS homebrew community that make projects like this possible. If you like the video, please consider giving it a thumbs up and subscribing. Thank you very much for watching. See you in the next one.